Hello my people, you all are welcome to my YouTube channel. This is actually my first video on YouTube, my first official video on YouTube. And I know majority of you are coming from TikTok, from Facebook and all that. So if you are just joining this page or this YouTube channel for the first time, ensure you like this video and please ensure you follow me, because what I'm going to do today is something that has never been done before. So please like this video, subscribe. Very, very important. So I'm not going to waste time. We're just going to run through what the 40 likely questions that you will see on the day of your exam. Now, the reason why I made this video is because a lot of people during this period of Jamb, most people did not attend tutorials. Yes, and most of you don't attend tutorials. Most of you, even when you attend tutorials, topics like chemistry, you will still find it very difficult to understand. And chemistry is very, very simple. Yes, and so because of this, that is the major reason why I'm making it. I mean, some of you say you go to work, so you didn't have time to go attend tutorials or even read on your own. So I believe with this, with this video, you can still enter the hall and still score at least 70 in chemistry. So please, like I said, subscribe and like this video. Thank you very much. So we're not going to waste time. We'll just run to the questions, I will answer it and I will explain. Because in the Jamb now, they might twist the question. They might not just bring it exactly like this word for word. They might just change one or two things. So that's why as I'm giving you the answer, I'm explaining it so that in case you see it in another form, you're able to still answer it. Do you understand? So let's go. Number one, the purest form of natural water is what? The purest form of natural water. This question is a commonly repeated question. Now the answer is what? What's the answer? What's the answer? The answer is what? Rainwater. Now you might ask Dr. Austin, why is it rainwater? Now the reason why the answer is rainwater is because rainwater is formed from what? From the condensation, from the evaporation and condensation of water. For example, now, if you go to like a very big sea now, there's water everywhere in a sea. Now, when there's heat like sun, maybe during a very sunny day, the surface of the water is being evaporated. Then to go to the atmosphere. And when it gets to the atmosphere, the water will be held there. After some time, the water that is being held in the atmosphere will be so heavy that the atmosphere can no longer accommodate it again. So the atmosphere will now bring it down as rain. You understand? So rain is actually the purest form of natural water, because it is formed from the evaporation and the condensation of water. And sometimes hotel will tell you that it is formed from natural distillation. But like I said, the purest form of water is rainwater. Why is it not spring water? Because spring water have some dissolved minerals in it. Why is it not river water? River water have some particles in it. You understand? Why is it not lake water? These ones sometimes they have impurities in it. So all these ones are not natural form of water. It is this one that is the purest form. Please take note. After rainwater, we will now have spring water, before river and before lake. But the most purest is rainwater. Please, rainwater. Question 2. Which of the following react with water? Sorry, which of the following react with water at the fastest rate? We have calcium, magnesium, sodium, and iron. Now, when it comes to chemistry, we have group 1 elements, we have group 2 elements, we have group 3, we have group 4. Now, elements under group 1, let me use here. Elements under group 1. Elements under group 1, a good example is Potassium, sodium. Now, these two guys, they are the major guys in the group 1 element. They are group 1 element. Now, these guys, they are called alkali metals. Why? Because they react with water very well to form a base or an alkaline. Yes, they react with water to form an alkaline. That's why it's called alkali metals. Now, take out that, for example, now if I take sodium now, small sodium, and let me say I just throw it inside a bucket of water, that water will just explode like vroom. Why? Because sodium reacts violently with water. Because sodium and potassium, they are very reactive. You understand? We also have group 2 elements too. Yes, we also have group 2 elements. Examples of group 2 elements, we have calcium and magnesium. These two guys, they also react with water, but the way they react with water is not the same way group 1 reacts with water. Group 1, they react very fast with water. So because of that, we will say that group 1 element react vigorously with water. So, and like I said, members of group 1, the major members in group 1, calcium and what, and sodium. Group 2, sorry, potassium and sodium. Then group 2, calcium and magnesium. You understand? So looking at the question again, which of the following react with water at the fastest rate? A, calcium, magnesium, sodium, and what? Iron. Which is the answer here? The answer should be what? The answer should be what? Sodium. Yes. Because sodium, all of them can react with water. Like I said, this calcium and magnesium, they are other group 2 elements. In fact, group 2 elements are called alkaline earth metals. Please take note. Group 2 elements are called alkaline earth metals because they also react with metals to form alkaline. But the way they react is different from the way group 1 react. Group 1, you not get jewel. Group 1 not get jewel at all. My 40 years. Most of you know that trend on TikTok. So, yes, like I said, so calcium and magnesium, they react with water, but not as fast as sodium. This one, iron reacts with water, but it only reacts with water in what? In a steam form. Yes, steam. In the form of steam. That is how what iron reacts with what? Water. In the form of steam, not ordinary natural water. Not ordinary water. Water that has been heated to be what? To turn to steam. That's the only one that reacts with what? Iron. You understand? So the correct answer is what? C. Sodium. Please take note. No time. Now look at this one. Which of the following makes oil distinguish from fat? The question is that, we have fat and oil. You know that one, fat and oil. Now what they're asking us now is that, what's the difference between fat and oil? This question, it comes out a lot in the exam. Now the simple answer is that the difference between fat and oil is that fat is what? Is saturated. Fat is what? Fat is saturated. Fat is what? Let me use this marker. Fat is what? Fat is saturated. Fat is what? Saturated. While oil is what? Unsaturated. So what did I say? Fat is what? Is saturated. While oil is what? Unsaturated. That's the only difference. So their degree of saturation is what differentiates fat from what? From oil. Their degree of saturation. Fat is what? Saturated. Oil is what? Unsaturated. Please take note. Question 4. Which pollutant contributes to the depletion of the ozone layer? Now it's very, very simple. The pollutant that contributes to the depletion of the ozone layer is what? CFC. You might ask me now, Dr. Austin, which one is CFC? What the full meaning of CFC? The full meaning of CFC is what? Is chloro. Okay, I know you guys cannot. I don't think you guys can see this one. Let me use black. It is what? Okay, let me use red. Sorry, I have different markers. Just to make sure that you remember it in the exam, but that's why I'm using different markers. It's called chlorofluorocarbon. Chlorofluorocarbon, that's CFC. Chlorofluorocarbon is what causes depletion of what? The ozone layer. You'll see it on your exam. Question 5. It said the compound used as antifreeze in car radiators in cold regions. Now take note that in cold regions now, it's not Nigeria now that everywhere is hot. If you go to countries like, I think, Austria is very cold. You understand? Yeah, Alaska and all of them. These regions are very, very cold regions. And most people, when they want to like start their car, usually have issues starting their car, because when the engine is cold, it will be hard for the car to start. You understand? So what happens is that these people, when they want to fill in their radiators, they add what? A chemical substance. And this chemical substance will prevent what the essential part of what the car from freezing. So anytime they wake up the next morning, they can easily start the car. That substance that acts as what? An antifreeze. The antifreeze. That as what? An antifreeze in the car, in car radiators in cold regions is known as ethylene glycol. Yes, it's known as what? Ethylene glycol. Either you call it ethylene glycol or you call it what? Ethane 1,2-diol. Yes, ethane 1,2-diol or ethylene glycol. Please take note. Either you call it ethane 1,2-diol or ethylene glycol. Now, question 6. Let's go. Now, question 6. It says silica gel, when exposed to the air, turns into liquid. What kind of substance is it? Now, you expose silica gel to air and it turns to liquid automatically. What's that thing called? Now, take on that we have three guys here: deliquescent, hydroscopy, and efflorescent. Now, what's the difference between these three? Now, when you expose something, listen to my grammar. When you expose something, okay, let me leave there. When you expose something to the atmosphere, and that thing absorb moisture, it absorbs moisture to now become a liquid. It absorbs moisture to become liquid. That thing is what deliquescent. But when you expose something to the atmosphere, and that thing absorbs moisture but does not turn into liquid, it just becomes a little bit softer. That's what hydroscopy. But when you expose something to the atmosphere and that thing loses its water crystallization, that's what efflorescent. So which one absorbs moisture to turn to liquid? That's why it's called deliquescent. There's liquid inside. They absorb moisture to form liquid. Hydroscopy, moisture to become moist. It's not fully liquid, it just becomes moist, a little bit softening. Then efflorescent, it loses its water of what? Crystallization. So look at the question again. Say silica gel, when exposed to the air, turns into liquid. What kind of substance is it? The answer is what? The answer is what? The answer is what? It turns into what? Liquid. That's the key word. It turns into liquid. And the answer is what? Deliquescent. Very, very correct. Please write it. It's very correct. So now, the salt responsible for temporal hardness of water. The salt responsible. Now take note that when it comes to what the hardness of water, we have two. We have temporal hardness and we have permanent hardness. Now, temporal hardness is caused by calcium hydrogen trioxocarbonate, or you can say it's also caused by magnesium hydrogen trioxocarbonate. You understand? But permanent hardness, anything can cause it. Permanent hardness is caused by calcium sulfate, magnesium sulfate, magnesium chloride, calcium chloride. All these guys, they are all what? Caused by, all these ones causes what? Permanent what? Hardness. Permanent. But these two, they what? They causes what? They cause what? Temporal hardness. Temporary what? Hardness. So looking at what I just explained now, which one is the answer here? Which one is the answer? Which one is the answer? The salt responsible for temporal hardness of water is what? Is what? The answer is what? Calcium hydrogen trioxocarbonate. This one, they all cause what? Permanent hardness. You understand? Now look at this one now. Where is my duster? Give me a second. Now look at this one. Let me clean this place, but this is where I'll be using to explain things. If you know that you are learning, and please just type in the comments that I am learning, sir, so that I know that I'm not just teaching myself. So now look at this one. It said the functional group in the compound above is what? The functional group in the compound above. Now let me tell you something. In your Jamb exam, please take note of these guys. We have what? ROOH. We have ROCOOH. We have ROORO. We have ROCOORO. We have ROCHO. We have ROCORO. Yes. Now, all these guys are called what? Functional group of what? Different what? Organic compounds. Now, whenever you see a organic compound that ends with OH, or that has a functional group of OH, just know that compound is what? Is an alkanol. Please take note. Is an what? Is an alkanol. Yes, when it ends with OH, is what? An alkanol. But when it ends with COOH, when an organic compound has a functional group of COOH, that organic compound is what? Is an alkanoic acid. An alkanoic acid. Please take note. Now, when a compound has a functional group of just O, like this, this compound is called an ether. is called an ether. But when a compound has a functional group of COO, that's what compound is called what? An ester. An ester. Or you call it esters. You understand? Now, when a compound, let me write this one down. Let me bring this one a little bit down. Let me bring it a little bit down. That's what did I even write there? Sir? Arrow C O arrow. Abi? Yes. So now, when a compound has a functional group of CHO, that's what compound is. What is an alkana? An alkana. An alkana. When a compound has a functional group of CO, is what is an alkanone. Is an alkanone. So having known all this, please write this thing down. You come out to your exam. Any of them will ask you any of them. You understand? So looking at this guy now, look at this compound. You can see that this compound is having what? All these arrows, they are carbon atoms, so, or they call them alkyl groups, but you can call them carbon atoms. So imagine now, I now visualize this thing to now become arrow C H O. So we have arrow C, there's H obviously, and there's what? O. So what does this, like, what is now this compound? Like, what is this, or what does this, what's it called now? What does this functional group tells us? Like, which member has this functional group? From what I've been saying so far, because you can see this carbon atom is the same thing as the arrow, the alkyl group. And then there's C, there's H, and there's O. So which one has arrow CHO? Is what? Alkana. So alkana has the functional group of what? Arrow CHO. So please see the one that you should know where is alkana, alkanone. Alkana, arrow CHO. Alkanone, arrow CO arrow. You understand? Now take note that there's a relationship between alkana and alkanone. That relationship is that they have what? A carbonyl group. They both of them have the same carbonyl group. They share the same what? Carbonyl group. That is why alkana and alkanone, they are what? Quite related. But apart from that, take note of their what? Different what? Functional group. They are different, or you can say they are different general molecular formula. Anyone. You understand? One is arrow CHO, one is arrow CO arrow. Please take note. Now, the following compound, okay, yeah, it's supposed to be the following compound can undergo both addition and substitution reaction. Can undergo both addition and substitution reaction. The answer is what? The answer is what? Somebody tell me. The compound that undergo both addition and substitution reaction is what? Is benzene. Please take note. Benzene is what you see on the day of your exam. It undergo both addition reaction and substitution reaction. Now look at this one. It said the repeating unit of natural rubber is what? Now look at this one. It said the repeating unit of natural rubber is what? The repeating unit of now take note that when it comes to rubber, we have two types of rubber. We have natural rubber and we have what? Artificial rubber or man-made rubber. You understand? Now there's a particular tree that natural rubber is gotten from. Those of you that grew up in the village, people like me. I grew up in the village. I did grow up in the village, but I've been to the village. There's a tree, I think it's called the Avesian. I can't remember the exact name of that tree, but that's the tree that they used to make what? Natural rubber. Now think about that natural rubber, natural rubber. The name, the repeating unit of natural rubber is what? Isoprene. This is what for natural rubber. Then for artificial rubber is what? Neoprene. Yes, is neoprene. Isoprene, natural rubber. Neoprene, artificial rubber. If you don't see these two guys, the one you will see, they will tell you that another one is what? They will tell you that 2-methyl but 1,3-diene. 2-methyl but 1,3-diene. 2-methyl but 1,3-diene is the repeating unit of what? Natural rubber. But neoprene is 2-chloro but 1,3-diene. So this one, isoprene, This isoprene is for what? Is for natural rubber. Isoprene, natural rubber. But neoprene is what? Artificial rubber. You say man-made rubber. Please take note. Please take note. Oh, they will ask you. They will ask you, if you don't see isoprene, you see 2-methyl-butanol-3-diene. If you don't see neoprene, you see 2-chloro-butanol-3-diene. So please take note of this. Very, very important. So now we are moving on to the what? To the next set of videos. So please follow me. If you're not following me, and subscribe and like this video. And if you're enjoying it, let me know in the comment section that you are enjoying it. Now we want to start entering some dangerous questions now, because the one we did first, those ones is charges, those are baby questions. Now this is time for us to what? To enter the top questions. So please pay attention. Very, very important. So what we'll do is that you can see there are some calculation questions here. So we'll first of all answer the ones that does not involve calculation. They will clean it, so we can use that place for what? For calculation. You understand? So we will not answer this one. We will not answer this one first. We'll answer this question 12 downward, so I can clean it and use to calculate this particular, this particular question. You understand? So now, question 12. It says steam changes the color of anhydrous cobalt 2 chloride from. Now, steam. What is steam? Steam is still water. I hope you know. Now, take out that water. Normally, the normal water that we all know, that's a normal H2O. Normal, let me not use marker. I just want to use another marker so that you don't get confused. Now, H2O normally is water in what? In liquid form. You understand? But when the water is now in gaseous form, that now becomes what? That becomes steam. You understand? So, in other words, what you're trying to say is that water changes the color of anhydrous cobalt 2 chloride from what? Now, take out that there's a test for water. Hope you know that water is colorless, tasteless, and odorless. Excuse me. Hope you know that water is odorless, tasteless, and colorless. So there are some times where you'll be in the lab, you see two substances. One is looking like water. The other one is looking like water. Why will you know that okay, this one is really, really water, and this one is not water? How will you now know? It's by testing for water. Now there are two compounds that you can use to test for water. The first one is what? This cobalt 2 chloride, and the second one is what? The second one you can also use to test is copper sulfate. You understand? Now, when you use cobalt 2 chloride to test for water, the color is from what? From blue. From blue to pink. From blue to what? To pink. So when you use cobalt 2 chloride to test if that thing is really water, and then this cobalt 2 chloride now turns from blue to pink, it means that true, it is what water that is there, because only water that converts what? Cobalt 2 chloride from blue to pink. Please take note. But for copper sulfate, if you put copper sulfate inside water, it will convert from what? From white. To convert from white to what? From white to blue. Yes, from white to what? To blue. So please take note. Cobalt 2 chloride, put inside water, blue to pink. Copper sulfate, put inside water, white to blue. Please take note of this. Very, very important. So when steam changes the color of anhydrous cobalt 2 chloride from what? From blue to pink. We've answered that one now. Now, question 13 says, which of the following will change when a catalyst is added to a chemical reaction? Now, those days when we're growing up, there was this then it's not now that then those days, if you want to cook beans, beans takes time for it to get ready. So what they do that time is that they normally add this thing, alum. I think I say alum, or I can't remember, or potash. I can't really remember, but there's a substance they normally add to beans. If you know it, just drop it in the comment section. That will make that beans get ready on time. You understand? Even if it's supposed to like get ready in like, let me say 30 minutes, because of that alum that you added, or that I think it's alum or potash, I don't really remember. It will not get ready in less than 5 minutes or 10 minutes. You understand? So that substance now that speeds up a reaction. Hope cooking is a reaction. So that substance that speeds up a reaction is known as what? A catalyst. So a catalyst what speeds what? A reaction. It makes the reaction to become done faster, to get to its product faster. You understand? So one thing to know is that how does the catalyst does this? The catalyst will now what? The catalyst will lower the what? Activation energy. Yes, it will lower what? The activation energy or for that reaction, making the reaction to get ready on time. So that's it. That's how a catalyst works. A catalyst will, for example, now, if I give you a fence now that is high like this, maybe high like this now, and a fence that is like this, between these two fences, which one can you easily jump? It is what the lower one. This one, it will take you time. You understand? So what the catalyst does is that the catalyst will now lower the activation energy to this point, so that the reaction can quickly what happen. Do you understand? So that's how a catalyst works. So we'll say a catalyst simply what the following will change when the catalyst is added to a chemical reaction. The catalyst will lower the activation energy. That is what a catalyst does. It lowers what the activation energy. Finish. It does not change the product. It does not change the equilibrium constant. Nothing changes. It just lowers the activation energy, making the reaction to become faster. Now look at this one. I say the process that converts an ethanol to an ethanoic acid is what? Now take out that ethanol is what? Is a member of the alkanol. Please don't forget to. Why ethanoic acid is a member of what? Ethanoic acid. I want to explain something. So the process whereby an alkanol, a primary alkanol, please, let's be specific. A primary alkanol is converted towards an alkanoic acid is called oxidation. It's called what? Oxidation. Please take note. It's called oxidation. Now we have what we call partial oxidation, and we have what we call complete oxidation. Now partial, please write this thing down. Partial oxidation of what? Primary alkanol forms alkana. Partial oxidation forms alkana, but complete oxidation forms alkanoic acid. So you can see that the process that converts an alkanol, a primary alkanol, to an alkanoic acid, that is ethanoic acid, is called what? Oxidation. Complete oxidation. But if you say partial oxidation, it is what? Alkana that will be formed. So alkana is only from the partial oxidation of what? A primary alkanol. But the oxidation of a secondary alkanol forms what? Alkanol. Please take note. Please take note. Take note. Write it down. I cannot write it here because I don't have space. Partial oxidation of primary alkanol causes what? Alkana. Complete oxidation of primary alkanol from primary alkanol forms what? Alkanoic acid. But oxidation, whether partial or complete, of a secondary alkanol forms what? Alkana. So let me just, should I write it down? But you guys will get it now. There's no time. Please just don't take note of this. Complete oxidation of primary alkanol, complete alkanoic acid. Partial oxidation of primary alkanol, alkana. Oxidation of what? Secondary alkanol is what? Alkanol. Please take note. Now the structure of diamond is what? The structure of diamond is what? Is tetrahedral in shape. Is what? Tetrahedral in what? In shape. Now take note that diamond is an allotrope of carbon. I hope you know. We have carbon. Carbon is divided into two allotropes majorly. We have a diamond and graphite. Now the shape of diamond is tetrahedral in shape. While the shape of graphite is what? Is trigonal. Trigonal planar. Trigonal what? Planar is the shape of what? Of what? Of graphite. Please take note. While the shape of diamond is what? Tetrahedral. Now, look at this one. The presence of impurities will cause the melting point to do what? Now take note that the presence of impurities increases the melting point. Please take note. The presence of impurities increases what? It doesn't lower the melting point. Oh. Sorry. I just made a mistake. Please take note. The presence of impurities will cause the melting point to dash. The presence of impurities will cause the melting point to dash. Now take note that impurities lowers the melting point. Yes, impurities lowers what? The melting point. Lowers the melting point. Let's just write it there. It lowers it. It lowers what? The melt. Let me write it so that some of you not go and make mistake, because it lowers the melting point. It does what? It lowers the what? Melting point. For example, now in the cold regions, yes, where there are some, not Nigeria or where there is snow. You understand? You can leave the countries. Most of them, you watch it in films. Now, on the surface of those in those countries now, when it's snowing, the surface is covered with ice. So what happens is that these people, they will take salt and they'll pour it on top of that ice. When they pour it on top of that ice, the ice will now melt faster, because that salt is acting as an impurity to the ice, making the ice to melt faster. So you can see that impurities actually lower the melting point. You understand? So we are done with all these questions now. So let's solve this particular one. Let's solve this particular one now. That is yeah. It said one current in amperes will deposit 2.7 grams of aluminium in 2 hours. Now, this question is under electrolysis. Now, there's a formula. I don't know if you have been following me on TikTok, you will have an idea on how to solve this question. Now, the formula I posted on my page on how to solve questions like this is this question is under what? Electrolysis. Yes. Now, don't forget to follow me on my TikTok. There's a formula I dropped then. I said IT equals to NQF. You understand? I is what? The formula of I is what? Is current. Please, this formula, just learn it. It can solve any question. 80% of the question in electrolysis, this formula can solve it. 80% of all the questions, this formula can solve it. I is current. T is what? Time. N is what? Number of moles. Number of moles. Q is what? Is charge. YF is what? 96,500. Now, if I break down this formula, IT equals to, like I said, N is number of moles. And number of moles is what? Mass over molar mass. So I can say IT is equals to mass over molar mass times Q times what? F. Now remember, they said what current in amperes will deposit 2.7 grams of aluminium. So we're looking for the current. What current? They say what current? What current? That's what we're looking for. Look for the current. So now what did they give us in the question? They gave us what? Did they give us current? No. It's current is what we are asked to find. Did they give us time? Time, yes, they gave us time. But the time is in what? Is in 2 hours. They gave us time, but the time is in what? Is in 2 hours. 2 hours. Now, wait, so let's go down. Number of moles, did they give us? No. But they gave us the mass and the molar mass. The mass is 2.7 grams. The molar mass is 27. So we can say that the mass, since because number of moles is mass over molar mass, so we can say that the mass that they give us is what? Is 2.7 grams. Then the molar mass from the question is what? 27. Because I say aluminium is what? 27. Now, what is the charge? Now, aluminium has a charge of 3. Now, that does not seem. Why does it have a charge of 3? Because aluminium is in group 3. When aluminium, for aluminium to become ionized, it has to donate for 3 electrons. So aluminium is what? Has a charge of what? Of 3. Please take note. Sodium has a charge of what? +1. Calcium has a charge of what? +2. Aluminium 3. Please take note. Very, very important. So now the F is what? 96,500. So having known this, we're looking for current, Abby. So let's make current subject to the formula in this question. So in order to make subject to the formula, we can just divide both sides. To make it easy, just divide both sides by T. If you divide both sides by T, you've already gotten, you make I stand alone. So let's say I divide both sides by T. I divide both sides by T. So T will now cancel T, Abby. So the I will now be equals to mass over molar mass times Q times F over T. Then I, but we're looking for mass is what? 2.7 over molar mass, which is 27, times the charge, which is 3, times, let me bring it down so I don't confuse you. So let's say I is equals to mass is what? 2.7 over molar mass is 27 times charge, which is 3, times F, which is 96,500. everything over time, right? Yes, time is what? 2 hours. But think of that when we are solving, we will not use 2 hours to solve. We have to convert it to what? To seconds. So to convert hours to seconds, what do? We multiply it by 60. Multiply it by 60, we convert hours to minutes. Then we multiply again by another what? 60. We convert another 60, we convert the minutes to what? To seconds. So to convert hour to seconds, we have to multiply by 60 2 times. To convert hours to seconds, we multiply by 60 2 times. So what we're now left with now? We're now left with what? I equals to 2.7 divided by 27. Let's check that. I don't want to be very fast, I beg. 2.7 divided by 27, that's 0.1. 0.1 times 3, then times 96,500. You have 28,950. 28,950. Divide both sides by 2 times 60 times 60. 2 times 60 times 60. 2 times 60 times 60 is 7,200. 7,200. What you do is that 28,950 divided by 7,200 is what? 28,950 divided by 7,200 is what? Is 4.0. 4.0. So the current is 4.0 amps. So this is how to what? Solve this question. So after getting, you can see the answer is even there, 4.0. So you can see that the option there is what? Option C. So we've gotten the question already. Hope you understand. So just the major thing is that just memorize this formula and you are good to go. IT equals to NQF. You can solve any question. And this N is number of moles. And number of moles is mass over molar mass. Because sometimes they'll give you the mass and the molar mass. Sometimes they'll just go direct. They'll just give you the number of moles of the aluminium. So you just use it direct. They give you just the number of moles. But they give you the mass, and if they give you the mass and the molar mass, you will now have to break it down like this. You understand? Then you get it. So this we'll solve this question now. So now let's go over to the next guy. Now what will happen is that we'll solve these ones. We'll answer them, then we'll clean it so that we can to solve this particular question. So question, look at it. It said when methane burns in excess air, it gives what? Now take on that methane is or methane is an organic compound. Yeah, methane is an organic compound. So and take on that all organic compounds undergo combustion, meaning that when you burn an organic compound in excess air, you will get what? CO2 and water. For example, now this is methane. Let me write the chemical reaction. This is methane, CH4. When you burn it in oxygen or in excess air, it gives what? CO2 and what? And water. Yes, it gives what? CO2 and water. The reaction is balanced. So this is what? Methane reacting with oxygen to give CO2 and what? And water. Please don't forget this. Don't forget this. Any organic compound that you burn in excess air must give CO2 and water. So now, look at this second one. Which of the following elements is common to both steel, alinco, and primallory? Now, take note that all these are alloys. What are alloys? Alloys are formed by mixing different metals together, mostly transition metals. Yes, when you mix metals together, you get what? You get an alloy. You understand? So we have steel. Steel is a mixture of metals. Now the two metals that mainly make steel is what? Is iron. That's iron and what? And carbon. It is iron and carbon that form steel. Therefore, alinco, it is aluminium. Sorry, let me use on that marker. For alinco, it is what? It is aluminium. It is nickel. It is what? Cobalt and what? Iron. Please take note. You can see it. Anico. It's not alinco, it's anico. Sorry. I was saying alinco. It's anico. Anico. Yeah, that's aluminium, nickel, cobalt, and iron. Then primallory is also what? An organic compound. I think primallory is built up of iron and nickel. Yes, iron and nickel. So what do you observe? You observe that all this compound, there is what one more element that is common among them. Now that is what? Iron, iron, and iron. So you can see that all of them share a common what? A common element known as what? Iron. Please take note. 20. He said, which of the following will favor the production of X? Now, this question is under chemical equilibrium, and chemical equilibrium is a question that will always come out to your exam. Now, look at it. Listen attentively. To solve a chemical equilibrium question, first of all, look at the reaction. Ask yourself, is it an endothermic reaction or an exothermic reaction? Now, tell you that we have two types of reactions. So we have endothermic and we have what? Exothermic. Now, you said, Dr. Austin, what is exothermic and endothermic reaction? Now, when a reaction releases oxygen, when a reaction releases heat to the atmosphere, it is called what? Exothermic. Release heat. When it releases heat, is exothermic. When it absorbs heat, is what? It is endothermic. That's why it's called endo. It absorbs heat. Please take note. Absorb heat. Now, take note that another way of knowing it is by looking at the reaction. If you look at the reaction and you see that delta H is positive, it means that reaction is what? An endothermic. But if you see delta H is negative, it means that reaction is what? Is exothermic. So looking at this reaction now, first of all, ask yourself, is this an endothermic or an exothermic reaction? It is what? An exothermic reaction. But to make things easier for you, let's just imagine that this reaction is what? Is endothermic. To make this easier, what will happen is that if I increase the temperature, for an endothermic reaction, it will favor the what? The right. Equilibrium position will shift to the right for an endothermic reaction. But if I decrease the temperature, equilibrium position will shift to the left. So imagine now, I increase the temperature of this reaction that is endothermic. Equilibrium position will what? Will shift to the right. That is shift to the what? To the right. And that means that more product will be formed. Because yes, product, yes, reactant, yes, product. More product will be what? Will be formed. But if I now decrease temperature, equilibrium position will now what? Will shift to the left. Meaning that more reactions, that is less, that is more product, more reactant will now be formed. Remember, like I said, when you increase for endothermic, it will favor the forward reaction, more product. But when you decrease for endothermic, the backward reaction. So when I decrease temperature, the backward reaction will be favored. More reactant will be formed. Please take note. Now, apart from that, you can observe that they are all gases. But just to be safe. So what will I now do? Listen, what will I now do to have more reactants? That is, which of the following will favor the production of X? That is the reactant. So what will I now do now to favor more reactants? I will decrease the temperature. So you can say that to make more product, to make more reactant to be formed, we have to what? We have to what? Decrease temperature. We have to what? Decrease temperature. When we decrease temperature, it will favor the backward reaction. But when we increase temperature, it will favor the forward reaction. Forward and endothermic reaction. Forward and endothermic what? Reaction. Please take note. And how do you know endothermic reaction? Positive. So another way again that we can increase, more reactants, because if you observe, all these guys are gases. Please take note, they are all gases. So you understand? Therefore, gases and pressure affects gases. So when you increase pressure, take note, when you increase pressure, it favors the side with the lesser mole. So between this side and this side, which one has a lesser mole? This one has a mole of what? 2. Then there's invisible one here, that's 3. So this side has 3 moles. This side has just 1 mole, but there's invisible one here. So when I increase pressure, it favors the side with the lesser mole. So when I increase pressure, it will favor this side, because this side is what have the lesser mole. So apart from decreasing temperature, if I also increase pressure, if I also what increase pressure, I will favor what the side with what the lesser mole, which is what X2. That will also favor the production of what of X. So there are two things that will favor the production of X in this reaction. First of all, when I increase my pressure, favor the side with the lesser mole. When I decrease my temperature, to favor the backward reaction, which is this X part. Now the opposite of all these things I've been saying so far is what happens in an exothermic reaction. So let's see that one. Look at this one. Which of the following organic compound can be used to make perfumes? Now take note that we have what we call what esters. Yes, what is called esters. Esters. Yes, esters. Now these esters, they have a sweet smell. So because of that, they are used to make what perfumes. You understand? They used to make perfumes, even cosmetics and stuff like that, because of their sweet smell. Example, we have ethyl ethanoate, butyl ethanoate, octyl ethanoate. In fact, butyl ethanoate smells like sweet banana. Octyl ethanoate smells like orange. You understand? Pentyl pentanoate, I think that one smells like, I can't really remember. But just take note that all of them are like just listening, they are what? Esters. You understand? And they have what? Sweet smell. Because of that, they are used to make what? Perfumes. Please take note. Now take note that brass is an alloy of what? Brass. Now take note that when it comes to this guy, we have two major people. Please take note, we have two major people. We have what? Brass. We have brass and we have bronze. We have brass and bronze. Now take note that brass is made up of copper and zinc, while bronze is made up of copper and tin. Yes, copper and zinc. So what you observe that there's a particular element that's common between brass and bronze, and the answer is what? The common element there is what? Is copper. Yes, copper is present in both brass, copper is present in what? Both bronze. So please take note for this question 22. Brass is an alloy of copper, and what? And zinc. Please take note. Now, look at this one, 23. He said, ethanol is used in dash industry. Ethanol is used in dash industry. So that ethanol is used majorly in the what? In the brewing industry. Yeah, brewing industry. Yes. Now, don't see what is brewing industry. This industry that makes alcohol, beer, those normal stuffs. Is the brewing industry that does that. So ethanol is used in the brewing industry. It's also used in the pharmaceutical industry because ethanol is also used to make drugs, but majorly in the brewing industry. Please take note. 24. It says which of the following is used in the construction of aircraft? Now take note that duralumin is the answer, is what is used in the construction of what? Aircraft. Take note of this, very, very important. Anico is used to make permanent magnets. Sorry, used to make permanent what? Magnets. Soft soda is used to what? To join two metals together. Soft soda. You understand? Then bronze is used to make medals. You understand? And some artifacts. Now take note that soft soda is an alloy of, I think, lead and tin. Yes, soft soda is an alloy of what? Lead and tin. Now, the gas used for the treatment of cancer is what? Is radon. Please take note. Is what? Radon. The gas that is also known as what? A stranger's gas is what? Is xenon. Xenon is also known as what? A stranger's gas. You understand? And it is used in photographer's flashlight tube. Krypton and xenon is used to what? Is used in photographer's flashlight tube because it captures images at high speed. Past question. Now, okay, I'm supposed to solve this question. Oh yeah, now let's clean the board. Then we'll solve this question here. All right, so now let's solve this question 17. It said, find the empirical formula of the compound. Find the empirical formula of the compound that has 69% carbon, 15.3% hydrogen, and 30.7% oxygen. Now, this question is other what empirical molecular formula. It always comes to your exam. How do you solve it? It's very, very simple. First of all, write out the elements you are given in the question. To solve an empirical formula question, write out the elements you are given in the question. So in this question, we're given what? 3 elements. We're given what? We're given carbon, we're giving hydrogen, and we're giving what? Oxygen. So we'll write it down. We'll write it outside. So solution. We have what? Carbon. We have hydrogen. And we have oxygen. All right. So now, carbon, hydrogen, and oxygen. So what next? What next? What next? What next? What next? What next? Write out the elements under, write out what you were given under each of the what? Under each of the elements. So for carbon, we're giving 69. So we'll put it there. We'll put 69 there. 69, 69. Then for hydrogen, we're giving 15.3. So we'll put it 15.3. For oxygen, we're giving 30.7. So put 30.7. So what do you do that? The next thing we'll do is that we'll divide by what their, we'll divide it by their what? Their relative molecular mass. We divide by what their what different what relative molecular mass, and these are their relative molecular mass. So for carbon, we'll divide 69 by what? By 12. For hydrogen, we'll divide 15.3 by what? By 1. Then for oxygen, we'll divide 30.7. We'll divide it by what? By 16. So when you do this, what will you get as your answer? What will you get when you do all these things? What will you get as your answer? So listen, what will you get? Let me use my phone because I don't want to waste time. Start using my head to calculate. All right, so now 69 divided by 12 is what? We have 5.75. We have what? 5.75. Then 15.3 divided by 1. We have what? 15.3. The same thing. Then 30.7 divided by 16. 30.7 divided by 16 is what? Let's check it. 30.7 divided by what? 16 is 1.91. 1.91. So the next thing you do is that, so sorry, let me put it under here so that it will be what? 1.91. Yes, then this one is what? 15.3. What you do is that you divide both sides. Divide both sides by the smallest. By the smallest of the answers. Divide everything here by the smallest. And which one is the smallest? 1.91. So divide everything by what? By 1.91. So divide by what? 1.91, 1.91, and 1.91. So when you divide both sides, 5.75 divided by 1.91 is what? 5.75 divided by 1.91 is 3.0, or just 3. You get 3 there. Just put it there, 3. Then 15.3 divided by 1.91 is what? 15.3 divided by 1.91 is what? 8. 8. And 1.9 divided by 1.91 is what? Is 1. So you can say that for carbon, at the end of the day, for carbon, we had what? 3. For hydrogen, we had what? 8. And for oxygen, we had what? We had 1. You can decide to write it, so I can't leave it anyone. So this is the empirical formula of this particular question. This is your final answer. Hope you know I did it. First of all, I wrote out all the individual elements. Secondly, I wrote out what we're given for each of the individual elements. Thirdly, I divided all of them by their respective ROMM. Carbon was 12, hydrogen was 1, oxygen was 16, so I divided it. Then I got answers, obviously. Then I divide by the smallest of them all, which is 1.91. And that's why I got this one. So for carbon, I end up getting 3, C3. For hydrogen, I end up getting 8, H8. And for oxygen, I end up getting 1, O1, or just O. So that's the answer to this word, to this question. So now, we've gotten it already. Let's now solve this one. This one. He said, if, so hope you guys understand. I hope we've already gotten a how to clean it out to solve that one. So please, let's just do justice to it. If you're not copied, you can pause and copy. But let me just quickly solve that question 26. Oh, God. I'm tired, bro. What's a good child, yeah? What's your good child? Now look at question 26. He said, if 93 centimeter cube of SO2, the volume of SO2 is what? If because 93 centimeter cube of SO2, that's the volume of SO2. So the volume of SO2, that's volume of SO2, is what? Is 93. This is under Graham's law of diffusion in Boyle's law, in gas law rather. Diffuse through a porous partition in 14 seconds. Mean the time for SO2 is what? Is 14 seconds. He said, how long will it take the same volume of hydrogen sulfide? How long will it take the same volume of hydrogen sulfide? Like how long will it take the same volume? Meaning that the volume of the hydrogen sulfide is still what? 93 cm cube. They say how long, that's the time for the hydrogen sulfide, what we're looking for. We take the same volume of hydrogen sulfide. So the time of the hydrogen sulfide is what we are looking for. Remember, like I said, they have the same volume. So if they have the same volume, we're not using the volume again, because they're already the same thing. They will cancel out at the end of the day. So we need to use it. That will just take time. So now the formula to use, Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of what? The relative molecular mass, or the molar mass. You understand? Now, if we do this like that, let's say we introduce a constant. At the end of the day, mathematically, we can say that R1 over R2 is equal to the square root of M2 over square root of what? M1. That's what this statement means. You understand? And that's what this statement that's what it means. You get. So this formula we're using. So to make it easier for you, we are dealing with two gases here. We are dealing with SO2 and we are dealing with hydrogen sulfide. So I can say that the rate of SO2 over the rate of hydrogen sulfide, remember it's inversely, will now equal to the molar mass of what? The molar mass of, sorry, hydrogen sulfide, not H2S, not H2O, of the molar mass of H2S over the molar mass of what? SO2. You understand? So please take note. What will you do next? What's the rate here? What's the rate? The rate here is talking about the time. The rate for SO2 is what? Now the time for SO2 is what? 14 seconds. Abi? Yes. What's the rate for hydrogen sulfide? What's the time? That's what the time for hydrogen sulfide is what we're looking for. So we'll just call it, let's just put time there. That's what we're looking for. Equals to then the square root. Now, what's the molar mass of hydrogen sulfide? The molar mass of hydrogen sulfide is what? Hydrogen sulfide is like this. Hydrogen is what? Is 1. Sulfur is 32. So we can say that 1. Okay, let me explain it to you so you don't get confused. Hydrogen, let me use another marker. So the molar mass of hydrogen sulfide. This is hydrogen sulfide now. So if I want to find the molar mass, I would say, okay, hydrogen is what? 1, but there's 2 close to it, so it's 1 times 2. Plus S is what? Sulfur. Sulfur is what? 32. That's the RML of sulfur. So we'll break it down. 1 times 2 is 2 plus 32. Abi? Yes. So that's 2 plus 32 is what? 34. So it means that the relative molecular mass of hydrogen sulfide is what? Is 34. Yeah. Is 34. Divided by the square root of what? The molar mass of SO2. Now what's SO2? That's SO2 equals to sulfur is what? Is 32, right? Plus oxygen. Oxygen is what? 16. But there's 2 close to it, so that's what? Times 2. So we end up having 32 plus 32, and that's what? 64. So it means that the relative molecular mass of sulfur is what? Is 64. Now what will not happen? We'll still continue. 14 over T is equals to the square root of 34 is what? Now this is not a perfect square. Oh. Not a perfect square. And Jamb brought it, and Jamb will not give you guys a calculator of a perfect square. So, but let's just say that this part of question will not come outside. But let's just solve it. But according to them, the square root of 34 is 5.8. 5.8. 5.83. Over the square root of 64 is 8. You understand? So we are almost done. We cross multiply. Abi? So let's bring it up here. So we now have 14 over T equals to 5.83 over 8. Multiply. T times 5.83 is 5 is T times, let me rule this line here because some of you, before you get confused. So that's 14 divided by T, sorry, T times 5.80 is T times 5.83 equals to 14 times 8 is what? 14 times 8 is what? 14 times 8 is 112. 112. So you divide both sides by 5.83. 5.83, 5.83. So this one cancel this one. So T is now left with what? 112 divided by 5.83. 112, 112, 112 divided by 5.83 is 19.2 seconds. 19.2 seconds. So it means that the rate of diffusion of this compound is what? 19 of the rate of that the time for hydrogen sulfide is what? 19.2 seconds. Now what delayed us is because of the fact that 34 is not a perfect square. If here was a perfect square, just like this one, it should have been easier for us. Do you understand? So take note of this. Very, very important. So that's the answer. That's the answer. 19.2 seconds. Now take note that we also have what is called what? Amphoteric oxides. Now this amphoteric oxide, like I said, listen, this oxide they can react with what? They can react with an acid, they can react with what? A base to form salt and water. And a very good example of amphoteric oxide is aluminium oxide and zinc oxide. Yes, aluminium oxide, zinc oxide, these guys are what? Amphoteric oxides. Please take me, those are the two that there are a lot of amphoteric oxides, but you see aluminium, you see zinc, they are the two major what? Amphoteric oxide. They act as both an acid and a base, meaning that they can react to form salt and water, both of them. So we can say that amphoteric oxide can act as both an acidic oxide and a basic oxide. Please take note, amphoteric oxide, zinc, aluminium, lead, tin. You understand? All these are what? Amphoteric oxides. So 29. Which of the following gases is collected by upward displacements? Now this question, it comes out a lot and most people fail. Let me explain. Now take note that upward displacement is also the same thing as what? Downward delivery. Please take note. Upward displacement is the same thing as what? Downward delivery. Downward delivery. So another name for upward displacement is downward delivery. Now take note that gases that are collected by upward displacement or downward delivery, these gases are what? Are lighter than air. So because they are lighter than air, they are collected by what? Upward displacement, otherwise known as what? Downward delivery. A very good example that you normally test every year is what? Is ammonia. Yes, ammonia is a very good example that they test every year. Apart from ammonia, hydrogen gas. Apart from hydrogen, what's it called? Methane. Yes, these three guys, they are what? Majorly what? Gases that are collected by what? By upward displacement or downward. But the most one that they will ask you is ammonia. You understand? Now, like I said, we have upward displacement, otherwise known as downward delivery. So if we have upward displacement, otherwise known as downward delivery, it means that we also have downward displacement, also known as what? Also called what? Upward delivery. You understand? So please, like I said, take out of this one. Ammonia, hydrogen, and methane. These guys are collected by upward displacement, otherwise known as what? Downward delivery. Now, there are other gases that are also collected by downward displacement. By downward displacement. Yes. Now, these examples of gases that are collected by downward displacement, this type of gas, they are heavier than air. That's why they are collected by what? Downward displacement. Examples of these gases, we have chlorine. Chlorine gas is collected by what? By downward displacement. We also have HCl. Yes, HCl is also collected by what? By downward displacement. You understand? Take note, HCl, chlorine, they are collected by what? Downward displacement. But upward displacement, ammonia, hydrogen, and methane. Why? Because they are lighter than air. Why? Because they are heavier than air. There's one again, I'm still trying to remember it. You know, so if I remember it, I'll let you guys know. But take note that these are the examples. Do you understand? So now let's go. What's the oxidation number of chromium in K2CrO2O7? What's the oxidation number of chromium in K2CrO2O7? Now it's very, very simple. Now let's solve it. But okay, let's leave this one first. Let's solve other ones. We'll come back to this one later. 31, it said, who discovered the charge on an electron? Who discovered the charge? Now take note that who discovered the charge on an electron and who discovered electron is two different things. So, who discovered the charge? Look at it. Who discovered the charge on an electron? The answer is what? The answer is R.A. Millikan. R.A. Millikan. This guy is the guy that discovered what? The charge on an electron by performing an experiment known as what? The oil drop experiment. Is it oil drop? My name is related to oil. Yes, he was the one that performed what? That what? Experiment. And that experiment was that made him to what? To know the charge on what? On an electron. But taking that it was J.J. Thomson that discovered electron. It was J.J. Thomson that discovered electron. Ernest Rutherford discovered what? Protons. James Chadwick discovered neutrons. You understand? Please take out of all these names. Very, very important. So now, how many electrons are present in this what? This guy here. I believe you guys can see it. How many electrons are present here? You can see that the element X has what? An atomic number of 20 and is carrying 2 plus here. What does this 2 plus means? Now take note that this down number here is called the atomic number. Abi? Yes, it's called the atomic number. Listen. Now, the atomic number is what? Is 20. Now, this clearly shows that, listen, this clearly shows that the number of protons in this compound is 20. Right? Yes, it's 20. Now, for a stable element, number of protons is equal to number of electrons. Abi? Yes. But for this compound now, it's not stable. Because why? It is carrying 2 plus. It is already a charge. It already has a charge, so it's not stable. And this 2 plus means that he has given out 2 of his electrons. Like I said, the atomic number is what? 20. And like I said before, for a stable compound, number of protons is equal to number of electrons. Meaning that if this compound was stable, and the number of protons will be what? 20 protons and what? 20 electrons if it was stable. Let's just say it's stable. But now it's not stable because why? It's carrying 2 plus. it has given out 2 of its electrons. So they're not telling us now that how many electrons are now present in this compound. But looking at it now, it has given out 2 electrons, meaning that it will not be 2 electrons. It will not be, look at, it will not be what? 2 minus 20. That's what? 18. So that to tell us that the electrons is now what remaining what? 18 electrons. Please take note. It is now what remaining 18 electrons. Take note, it is now remaining what? 18 electrons. Take note that the number of protons does not change. Even if you accept electron or donate electron, it does not change. The electron that changes, because it's the electron that does electronic transfer that is involved in chemical reaction. Like I said, if there was nothing here now, let's say there was no 2 plus here, and they just ask what's the number of electron here, the answer would have been what? 20. Because if there's no ion outside, it means that that compound is stable. But looking at it now, it's carrying 2 plus at the top, meaning that it's not stable. It has given out 2 electrons already. But in a normal day, because the atomic number was 20, the number of protons and number of electrons is the same, 20. But it has given out 2 electrons. So it means that the electrons are no longer 20 again. It is now what? 18. Do you understand? So please take note. Very, very important. Very, very important. Now, look at this one. It says which of the following gives a silver mirror test to toluene? Now look at this one. It said which of the following gives a silver mirror test to toluene? Now the answer is what? The answer is what? The answer is what? The answer is what? An alkana. An alkana is what? An organic compound that gives a silver mirror. That gives a silver mirror. That gives a silver mirror. That gives a what? A silver mirror to toluene's reagent. You understand? Alkana. You remember? I think I was saying it in the previous video. Well, in the previous clip where I was saying that we have alkana, we have alkanone. They all, both of them share the same carbonyl group. But a way to differentiate them is by using what? Toluene's reagent. When you use Toluene's reagent for an alkana, it gives a silver mirror. When you use it for what? An alkanone, nothing will happen. So you can say that an alkana is differentiated from an alkanone by what? By Toluene's reagent. Why? Because it gives what? A silver what? Mirror. You understand? Some people will tell you that this test is called what? A silver mirror test, and it's only positive to alkana. It only works on alkana. Please take note. Now, 34. Which of the following is used in the vulcanization of rubber? Which of the following is used in the vulcanization of rubber? Now, it is used for what? The element that is used is called what? It's called what? It's called what? The answer is what? Is sulfur. Sulfur is that what element that is used in the vulcanization of rubber. Please take note. Now look at this one. He said the role of sodium chloride. This is sodium chloride, though. Before you start thinking on that thing. This is sodium chloride. He said the role of sodium chloride. The role of sodium chloride in soap production. The role of sodium chloride in soap production. In soap production is what? Take note that the role of sodium chloride is to decrease what? The solubility. Yes, is to what? Is to decrease what? The solubility. That's simply the role. Now take note that the process of forming soap is called what? Saponification. Please take note. The process of forming soap is known as what? Saponification. Saponification. Now, what saponification is the process of forming soap. And how is soap formed? Soap is formed when you react a triglyceride with an alkanone. Sorry, when you react what? A triglyceride with caustic soda or caustic alkaline. For example, now, let's say, okay, my body is filled up and I cannot clean anything now. But just take note that for saponification is a process whereby triglyceride, or in simple terms, is a process whereby fat or oil reacts with what? Caustic alkaline or caustic soda, that's sodium hydroxide, to give what? Soap. You understand? So if I carry fat and oil and I react it with sodium hydroxide, I will form soap and propanol-2,3 triol. You understand? That process is known as what? Saponification. It comes out in exam every year. They will ask you the hydrolysis. They might just say the hydrolysis of a triglyceride with caustic soda forms soap. Soap. Don't be that your parents make soap. They normally caustic soda is always involved. They do not put oil like normal oil, red oil. That's the reaction. Fat and oil plus caustic soda, also known as sodium hydroxide, also known as what? Sodium hydroxide, also known as sodium hydroxide, will give you what? Soap and what? 1,2,3 triol. Now, take that we have solid soap, we have liquid soap. If I use sodium hydroxide, I will form a solid soap. But if I use potassium hydroxide, I will form a liquid soap. Please take note. Please take note. So that's, and the role of sodium chloride is to reduce the solubility, to decrease the solubility. Yes, the role is to what? To decrease solubility. Decrease what? Solubility. Yes. Now, question 34. It said a compound that is oxidized to produce alkanoic acid. Now, I've said this before. Like I said, we have what? Alkana. We have alkanol. We have alkanols. I said oxidation of primary alkanol. Partial oxidation of primary alkanol forms alkana. But complete oxidation forms alkanoic acid. You understand? Then oxidation of secondary alkanol forms what? Alkanol. So for this question, I said a compound that is oxidized to produce alkanoic acid is what? Is it primary alkanol or secondary alkanol? It is what? It is primary alkanol. Primary what? Alkanol. Primary alkanols is what you will oxidize to get what? Alkanoic acid. And it must be what? A complete oxidation. Please take note, because a partial oxidation will give alkana, but a complete oxidation of primary alkanol will form alkanoic acid. Now, 35. The ratio of the following ions gives a blue precipitate with sodium hydroxide when dissolved. This question, Jamb likes it very well. Now, this question is under qualitative analysis. Yes. Now, it's very simple. Anytime you see anything like blue precipitate in your Jamb, I'm just giving you the trick. I'm giving you the trick that will solve the question, that will solve any question regarding all this color. Anytime you see anything like blue precipitate, your answer should just go for what? Your answer should just go for copper. Anytime you see anything like blue precipitate, your answer should just be what? Copper. Automatically. Anytime you see anything like green precipitate in your textbook, green, your answer should just be what? Iron 2. Iron 2. Your mind should just go to iron 2. Anytime you just see anything related to red precipitate or brown, or brownish red or brown precipitate, your answer should just go with what? Iron 3. Anytime you see anything like okay, but for this one, they don't normally ask this one, I think this one is something white. But taking that for these three, these are the most common ones. You see, for this one, green. You understand? This one is always red or brown, brownish red. Then anything blue precipitate is copper. So looking at what I just said now, which of the following ions gives a blue precipitate with sodium hydroxide when dissolved? Your answer should just be copper, obviously. They say green, iron 2. They say reddish brown, iron 3. Now, 36. Which of the following is obtained by condensation polymerization? I tell you that they will ask you that question in your exam, and the answer is what? Nylon. The answer is what? Nylon. Nylon is formed by formed by what? Condensation polymerization. And condensation polymerization is for nylon is when hexa-1,6-diamine react with hexa-1,6-dioic acid. Yes. As I'm telling you, since 2020 that I learned all these things. So it is nylon. Please take note. Now look at this one. It's an organic compound commonly used as a disinfectant. An organic compound commonly used as a disinfectant. When you say disinfectant, I mean like to kill germs. You understand? Now take note that it is phenol. That's the answer. Phenol is what is an organic compound that is used to what to is that is used as what as a disinfectant. Now, which of them is used to make drugs? The answer is what? Aniline. Which of them is used to make explosives? The answer is what? Toluene. You understand? Please take all these are past questions. All these are commonly asked questions. Take note. Look at this one. It says the constituent of air necessary for rusting. The constituent of air necessary for rusting. The constituent of air necessary for rusting. The answer is what? The answer is what? The answer is what? The answer is oxygen and what? And water. Or you can say oxygen and moisture. But this one is one that you see on your exam. Oxygen and water is what is responsible for what? For rusting. So this is why when you put an iron outside and after like 1 week, the iron will start to rust because of oxygen and what? And moisture. You understand? Take note that it's only iron that rusts though. It's only iron that rusts. The corrosion of iron is what is known as rusting. Every other metal, they don't rust. It's only iron that rusts. You understand? The corrosion of other metals have their own special name, but the corrosion of iron itself is rusting. So it's only iron that rusts. You understand? So take note, I beg. Now, the drying agent used for ammonia. The drying agent used for what? Ammonia. Take note that the drying agent for ammonia is quicklime. It's quicklime. What I say, the drying agent for ammonia is what? Is quicklime. Quick lime. And that's what? Calcium hydroxide. Now tell you that ammonia is a gas that is very hard to dry. Why? Because when you want to dry it with an element, it will react with that element. But you see quicklime, it does not react with quicklime. That is why quicklime is used to what? To dry ammonia. It was specifically made to dry ammonia. You understand? But take note that there's a compound or an agent that can dry all gases, and the answer is what? Silica gel. Shakatabaya. The answer is what? Silica gel. Silica gel is a drying agent that can dry all gases. Silica gel. Silica gel is SiO2. Yes, this is what silica gel. Last question. The agent that can dry all gases is what? Silica gel. You understand? Now, the one made specifically for what? Ammonia. The one made for specifically is what? Quicklime, calcium oxide. Yes. Now, question 40. The ability for carbon to form long chains is called what? Catenation. Everybody already know that one already. Catenation. 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 Apart from carbon, it's not only carbon that catenates to. Sulfur catenates to an extent. Phosphorus catenates to an extent. But the one that just does it normally is what? Is carbon. So, is there another thing? I think there are two questions that we did not solve. Oh. Yes, there are two questions that we did not solve. I'm sure of that. I think we did. Okay, this one is there. And there's one again that we did not. Okay, we solved this one already. Okay, is this one that we did not solve? So we're going to solve it now. So please follow me. Follow me. Let me just use here. I believe everywhere is just important, but I beg you should go and pause the video and oh yeah, look at it, look at the board, look at the board. We have what? K2 CR2O7. They said we should find what? The oxidation number of chromium. That's they said we should find the oxidation number of this guy. This is the guy they say we should find the oxidation number of. Now it's very, very simple. I think that for calculating oxidation number, you have to do two things. Any element like that's in group 1 has an oxidation number of +1. Example of elements in group 1, we have potassium, we have sodium. Mostly those two that I will ask you. Both of them have a oxidation number of +1. Then any element in group 2 has oxidation number of +2. A good example is what? Is calcium, magnesium. Any element in group 3 has what? An oxidation number of 3. A good example is what? Aluminium. You understand? Then take note that for oxidation number of hydrogen is always +1. The oxidation number of oxygen is always what? -2. +1 -2 +1 -2. Please take note. Now let's go. Look at this question now. It said K2CrO2O7. Let's solve it. Now, like I said, this potassium now is in what? Is in group 1. So the original number of group of potassium is what? +1. So other potassium will put +1. Oh, my is not writing. No. Oh my god. Okay, let's use red to solve. So we'll put +1. But you observe that this potassium is not standing alone. No. This potassium is carrying 2. So we'll say what? We'll say, sorry, let me make it easy for you guys to remember. So remember, it's carrying is +1 times what? 2. Let's go to the other element. The other element is what? Is chromium. That's what we're looking for. So we'll still write like that chromium. But the chromium is carrying 2. So it will be what? Chromium times what? 2. You understand? Plus oxygen is what? Like I said, the number of oxygen is what? -2. Abi? Yes, it is -2. But this oxygen is not just carrying alone, it's carrying 7. So it will be -2 times what? Times 7. Everything here is equal to 0 because this element is a stable compound. Everything equals to 0. So now, +1 times 2 is what? +1 times 2 is the same thing as 1 times 2, and that's what? 2. Plus chromium times 2 is 2 chromium. So that CrO times 2 is 2 CrO. Yes. Plus -2 times 7 is what? -14 equals to 0. Then 2 plus 2 CrO plus times minus is what? Minus. Then you put 14 there equals to 0. Abi? Yes. So we have what? 2 CrO equals to this -14 we cross. If -14 cross, remember this 0 is here, so let's put this 0 here. -14, if it's cross, it becomes +14. Abi? Yes. This 2 here is +2. But when it cross, it becomes what? -2. Abi? Yes. It becomes -2. So we're now left with what? 2 CrO equals to 0 plus 14, 14 minus 2. 2 CrO again is equals to 14 minus 2. That's 12, right? So divide by side, divide by 2. 2 cancel 2 here. So CrO is now equal to 12 times 12 divided by 2. That's what? 6. You understand? So it means that the original number of chromium here is what? Is 6. So if you want to name this compound, you say if you want to name this compound, since chromium is 6, you want to name it, you say I think it's potassium heptaoxodichromate 6. Yes, potassium heptaoxodichromate 6. You can see that 6 is from the chromium. Because why? The original number of chromium in this question is what? Is 6. You understand? You understand? Why there are some times where they will just give you something like this. Let me give you another. Hope you understand this one. So that they'll just give something like this and say, oh yeah, name. They'll give something like this. Let me say MnO4 minus. And I'll say calculate the original number of this Mn, that's manganese. It's very simple. Remember, but this one is not carrying minus here. So what the difference is that you will not equate it to 0 again because this compound is not stable. For what we said here, it's not stable because why? It is carrying negative now at the top. So after if you are equating it, you will equate it to -1 because it's carrying minus here now. Imagine, okay, for example, let's say we want to solve this one now. We're looking for the original number of manganese, abi? So we'll write it down, Mn plus oxygen. The original number of oxygen was -2, abi? So we'll say -2 is carrying 4 times 4 equals to, it cannot be equal to 0 again. Why? Because this guy is already carrying, this guy, there's minus here. There's minus here. So we'll put it there, -1. If it was -2 that is here, we'll put it -2. So after that one, it will not be easier for us to solve. We'll not say, okay, Mn plus -2 times 4 is what? -8 equals to -1. Then Mn again is now equals to plus times minus is minus. They put your 8 equals to -1. They'll say, okay, Mn again equals to -1. -1 there is already here. This -8, if it cross over, it becomes what? +8. Abi? Yes. So it will now be Mn equals to -1 plus 8. How do you solve something like this? You are owing somebody 1 naira and you already have 8 naira. Obviously, you give the person from your 8 naira. So it means that you're not owing anybody again. When is not left with you is what? Is what? Plus 7. Do you understand this? That grammar I just spoke. You are owing somebody 1 naira minus 1. You owe somebody 1 naira. Plus 8, you already have 8 naira. You will give that person the out of your 8 naira now, so that the person will not disturb you again. So if you give somebody 1 naira out of your 8 naira, what is now remaining in your hand? Plus 7. You understand? So I just solved something like that to explain to you. So that's how it works basically. So what I'm going to do is that we've solved the question. The remaining part of this video, I'm going to give you bonus questions. Now these bonus questions are strictly calculation questions, stoichiometry to be precise. Because some of you have been complaining that you don't know how to solve calculation questions, and that's what they used to finish you in your exam. So we'll just solve 3 stoichiometry questions, then we are done with chemistry. 40 questions, because it's actually 40 already, but I want to give you bonus of 3 questions to solve, then we are done. So please, let's go. All right, my people, this is the bonus questions. Now these bonus questions are for those students that are having calculation and difficulty in calculating physics and chemistry questions. So that's why I made this video, so that, because you see this question, this one, it will come out your exam. You understand? Even if it does not come out word for word, then I just change 1 or 2 things, but it's still the same question you see. You understand? So in case a question comes out like this, how do you solve everything? Listen attentively, just follow me, cram the process. I will try my best to explain it in a way that you understand. They calculate the volume in cm cube of oxygen. By now, hope you guys can calculate Boyle's law, Charles law, all those P1, V1 equals to P2, V2. Then you can calculate Charles law, V1 over T1 equals to V2 over T2. Those are the gas laws now. So that one, it still come out in your exam, gas law. The reason why I did not bring it up is because I feel every student writing chemistry should know gas law. You understand? It's not even hard. It's not hard. These are the main things. So look at the question now. Let's solve it. It said calculate the volume in cm cube of oxygen gas evolved at STP when a current of 5 amperes is passed through acidified water for 193 seconds. Now this question is under electrolysis, but it's not the normal electrolysis question. That's why I had to bring it out. Now remember, I think we saw one question under electrolysis. I said that you know, the formula is IT equals to NQF, Abi? And I said this N is what? Number of moles. And number of moles is mass over molar mass, Abi? Oh shit. Is equals to mass over molar mass. Now take note that this is for what? For normal chemical substances. But for gases, number of moles for gases is what? V over 22.4. This is the formula. This is just a formula. This 24 is follow the form. It's just a formula like this. V over 22.4 at STP. The number of moles of a gas is V over 22.4. But so that means that we can replace this guy inside here. We can use to replace it. So if we replace it, it will now be IT equals to V over 22.4 times Q times F. We are correct. We are very correct. So now, because why? Remember, we can still put mass over molar mass here, but because this is a gas question, because it says what volume in cm cube of oxygen gas. So you can see it, oxygen gas. That's how, because it's a gas, that's why we're not using this one. If a normal substance, we'll use this one. So now we already know that. Let's bring out what we're giving in the question. Now for the question, we're giving calculate the volume. The volume is what we're looking for. Let me solve here. The volume is what we're looking for, Abi? Yes. Evolved at STP when a current of 5 amperes, current I is 5 amps, is passed through acidified water for 193 seconds. So the time is 193 seconds. You understand? So we're looking for what? For volume. Now remember that take note, for oxygen gas, the charge for oxygen gas when it comes to electrolysis, please, I use God. See, I want to kneel down. Don't forget this. The charge for oxygen in electrolysis is 4. Please take note. 4. For oxygen is 4. Now the F is what? 96,000. I mean, yeah, 96,500. So having known everything, let's plug it to the formula. To make matter easy, let's just make V stand alone. So we can just cross multiply now. Then all here, all here. So that's IT times 22.4. That's IT, or you can say I is for current to times T times 22.4 is the same thing. You understand? Equals to 1 times V times F times Q. That's the same thing as V times Q times F. You understand? IT times 22.4. I times T times 22.4. 1 times V times Q times F is still V times Q times F. You understand? So what's the current? 5 amps. So under current to put 5. Sorry, but not make V stand alone. So to make V stand alone, you divide both sides by what? Q and F. So V will not stand alone. So you divide both sides by Q times F. Q times F. So this one cancel this one. Abi? So we're now left with V. So V is now equals to IT. That's I times T times 22.4 over Q times F. Abi? Yes. So now V is now equals to what? I. Can you bring it down? V is now equals to what? I is what? From the question, I is 5 times T is what? 103 seconds. Is in seconds, we need to convert. Times 22.4 divided by Q is what? The charge, which is 4 times 96,500. You understand? And that will give us about, I think it's about 56 DM cubes, something like that. But let's just calculate it. There's no time. Take like you see, you have calculation in your exam, but that one will be kind of slow. 5 times 193 times 22.4. That will give us, the up one will give us 21616 divided by the down one will not give us what? 4 times 96,500. That will give us 386,000. Yes. So if you divide the two, you will get 21616 divided by 386,000. Yes. So we now have, if let's bring the answer here, we have 0.056 dm cube. You understand? But they said calculate the volume in what? In cm cube, not dm cube. In cm cube. So to convert dm cube to cm cube, we will just multiply by what? By 1000. So if you multiply this guy by 1000, multiply it by 1000, because we're converting to what? To cm cube. So it will now be 1. It will now be, sorry, it should now be 1, cancel it, 1, cancel it, and 1, cancel it. So the answer is now what? The final answer is now 56 cm cube. Yes. So this was the final answer to this particular question. Do you understand? So that's that for that. So let's run. Now this question, is I will not solve it. I will not solve it at all. I will just tell you what to do. You solve it by yourself, because this one is, I've solved it before, self. So please, this one is like a classwork for you. Now, he said the amount of current that will be deposited, the amount of current, that's I, is what we're looking for. That will be deposited, that will deposit 21.6 grams of silver, meaning that the mass of the silver is what? 21.6 grams. I mean, 21.6 grams of silver in 72 minutes. The time is what? 72 minutes. I mean, yes. They say what was the mass of the silver. Now the same formula, IT equals to NQF. Now remember, they're giving us mass. This is the molar mass of the silver. So it means that this N can replace it with what? Mass over molar mass. So it will now be IT equals to mass over molar mass times Q times what? F. Now, what are we looking for? We're looking for the current. I mean, that's this I. So we can cross multiply. It will now be 1 times m times q times f is still what? M times q times f equals to I t times m is still I times t times m. Now, what I'm making such a formula? Current. So to make current such a formula, it will divide both sides by t times m. So it will now be t times m, t times m. So t times m cancel t times m. Current will now be equals to this guy, which is m times q times f over t times m. You understand? So now I will now be equals to m is what? M is mass, and mass is 21.6 grams, 21.6 times Q is what? The charge. Now take a look at the charge for silver. I did not mention it earlier. The charge for silver is always 1. Please take note. In copper is always 2. You understand? So charge for silver, Q for silver is 1 times 96,500 divided by T is time. But the time is in 72 minutes. We cannot use that one to solve. We have to convert minutes to seconds. And to convert minutes to seconds, we have to multiply by 60. So now be 72 times 60 times the molar mass. And the molar mass is what? 108. You understand? So this will give you your final answer. All these jargons here, if you do the calculation, you should get your final answer. So if, for example, now I say 21.6 times 1 times 96,500, I will have 2084400 divided by 70 divided by this guy, 72 times 60 times 108, sorry, times 108. That's 466,560. And this guy will give us final answer is what? Final answer here is 208, sorry, 208,440 divided by 466,560. This is about 0.447. That's 0.447 amps. This is the current. Yes, this is what the current that will deposit that stuff there. So yeah, this is the final answer. Please take note. It's not hard to solve. It's not hard at all. It's not hard. But I don't think we are correct. I don't think we are correct. I think the calculation is, I made a mistake in here. I'm supposed to be, I made a mistake in the calculation in this, the division was not correct. 2084, okay. That's I don't like electrolysis because of these are long numbers. 2084440. So I had 4.467. That's what I had. And funny enough, in this option now that we got now, it will be in the answer. But I just look at it and say currents cannot be in 0 point. So the answer will be 4.468 amps. So as you can see that the other one was 0.044. This one is 4. The two of them will just be there. But this is the correct answer, obviously. You can still confirm your calculation with your calculator rather. So we are left with this one, and this one. So we're going to solve it now on this part. So please, let's go. There's no time. Alright, so now after writing out the mole ratio, the next thing to do is that ask yourself, this honest question. What were you given in the question, and what are you asked to find? Looking at the question, they said from the question above, what mass of Kako3, that means we are looking for the mass of Kako3, will be required to produce 11 grams of calcium chloride, meaning that we're given 11 grams of calcium chloride. So these are the only two things that concerns us as far as this reaction is concerned, because this is what we're looking for and this is what we're given. So we'll bring it down. So when we bring it down, we'll have what? Calcium carbonate and calcium chloride. We have calcium carbonate and calcium what? Chloride. What's the mole ratio? 1:1. Abi? Yes. So now, what do you do next? Ask yourself, like I said, what were we given in the question? We're given 11 grams of calcium chloride. We cannot use that 11 grams of calcium chloride to solve. We have to convert it to what? Number of moles. Now to convert to number of moles is what? N is equals to mass over molar mass. The number of moles is what? What we're looking for, Abi? Yes. The mass from the question said 11 grams of calcium chloride, meaning that the mass is 11 grams. What's the molar mass of calcium chloride? The molar mass of calcium chloride is 111. You understand? Is 111. That's the molar mass of what? Calcium chloride. You can calculate it by yourself. The values are there. You understand? So the number of moles is now equals to what? 0.1 mole. If you do 11.1 divided by 111 is 0.1 mole. So it means that the number of moles of what? Of this calcium chloride is what? 0.1 mole. Hope you know how we got 0.1 mole, because from the question they gave us the mass already. So just to use number of moles, because of mass of molar mass, we get the number of moles. So now that we've gotten the number of moles, take note that now that we've got the number of moles, what now happens? If you watch, they have the same mole ratio. So this means that any number of moles that is here is what will also be what? Also be here, because they have the same mole ratio. If this one was carrying 2, and this one is carrying 1, we would have just say 0.1 times 2 to get the number of moles. Because this one, let's say for example, that this one was carrying 2 now, and already has number of moles here. To get this one number of moles, we have to just say 2 times 0.1. That will give us the number of moles of calcium carbonate. But here is 1:1. So it means anything that is here will also be here. So here will not be what? 0.1 mole. Because why? They have the same what? Mole ratio. That's the essence of mole ratio. You understand? So now that we already know the number of moles, is that what they asked us to find in the question? No, they say we should find what? The mass. What mass of calcium carbonate? We already know the number of moles already of the calcium carbonate. To get the mass will not be hard. It will not be the same number of moles equals to mass over molar mass. What's the number of moles? 0.1. Abi? Equals to what's the mass? That's what we're looking for, Abi? Yes. Over what's the molar mass? The molar mass of calcium carbonate is 100. Yes, it's 100. Just know it like that. It's 100. Don't forget. For some hydroxide just now we said it's 40. This one is 100. So that would have what? 0.1 equals to mass over 100. What do you do? Cross multiply. So 1 times m is m equals to 0.1 times 100 is 10. Is 10. So the answer is what? 10 grams. So it means that it is 10 grams. That's what the mass of what? Of calcium carbonate. Yes, this is what it is, 10 grams. So it's very simple. Just go over it again, you understand. First of all, write out the reaction. Second, write out the mole ratio. Third, bring out the things you were given. Bring out the things that mostly matters in the question. That is what you were given, and what you were asked to find. Then from there, plug in the values. Get the number of moles of this side, use it to get the number of moles of this side, then you cannot get the mass. Very simple, Shikina. So with that, we've completely solved the commonly asked questions and the possible questions that you will see on the day of your exam. I can assure you that if you listen to this video to this very end, it means that yes, you are going to pass this exam. You are going to get at least a 70 in this exam. If you have listened to this video to this very end, it means that this exam, chemistry, you passed already. You understand? So like this video, subscribe, and by God's grace, I will make videos on other subjects too, like English, physics. If you want to make a video on other subject, just let me know in the comment section. I'll make it. So like this video and subscribe. Follow me. Very, very important. And for the future generations, I'll be seeing these questions too, because this is not just for 2026 students, 2027, 2028, they'll also come across the video. Also do well to go through it because it will help you too. So that's all for now, guys. And most importantly, I really want you all to pass and get what a very high jump. So once you've written your exam already, do well to reach out to me and let me know if what we did in this video helped you, and let me know what your jam score so that we can celebrate together. I really, really love to hear from you all after the jam exam. So that's all for now, guys. I wish you all success and wish you what a very high jam score in chemistry, and overall a very high score that will give you admission into your dream course and into your dream school. That's all for now, guys. I remain Dr. Austin. Bye bye.